a situation which is actually +3, -1. Try to improve on the light situation. And let's see how these electric vectors, how they show up in the vicinity of these two charges. So here you see the +3 and the -1, relative units. And let's take a look at this in some detail. First of all, the length of the arrows again indicates the strength. It gives you a feeling for the strength. It's not very quantitative, of course. And so let's first look at the +3, which is very powerful. You see that these arrows all go away from the +3, and when you're closer to the +3, they are stronger, which is a representation of the inverse R² field. If you're very close to the -1, the arrows are pointing in towards the -1, because the 1 over R², the -1 wins. And so you see they're clearly going into the direction of the -1. Well, if you're in between the plus and the minus on this line, always the E field will be pointing from the plus to the minus, because the plus is pushing out and the minus is sucking in, so the two support each other. But now if you go very far away from this charge configuration, anywhere, but very far away, much farther than the distance between the two charges, so somewhere here, or somewhere there, or here, notice that always the arrows are pointing away. And the reason is that +3 and -1 is as good as a +2 if you're very, very far away. But of course, when you're very close in, then the field configuration can be very, very complicated. But you see very clearly that these arrows are all pointing outwards. None of them come back to the -1. None of them point to the -1 direction. And that's because the +3 is more powerful, and then there is here this point, and only one point whereby the electric field is 0. If you put a positive test charge here, the minus will attract it, the plus will repel it, and therefore there comes a point where the two cancel each other exactly. Now there is another way of electric field representation which is more organized, and we call these field lines.